Alright, hello. So I just decided on the fly that the tangent video will be a whole new video, its own video. So dropping back for a minute, what are the tangent identities? You got to memorize them. I could run through the whole rigmarole again about how we derived the identities, but I'm not going to waste my breath on it because you don't need it for your quiz. But so our sum identity number 3 will be for tangent. It'll be the tangent of alpha plus beta. And after a long derivation, we found that the tangent of a sum expands to be tangent of the first plus tangent of the second. So far I'm liking that. That seems exactly like I would want. Well, no, it's a big fraction. And downstairs is the number 1, and then the opposite sign, so minus. And then it's tangent alpha again, but it's times tangent beta this time. And that's it. Don't try to memorize why this is the way it is. Just memorize what it is. It's the sum of the tangent of alpha and beta, and then it's divided by 1 minus the product of tan alpha, tan beta. So the good news is the tangent of a difference is pretty much the exact same thing. It's still going to be tan alpha, tan beta. In the denominator, it's still going to be 1 and tan alpha times tan beta. And then just follow the same pattern for the operations. Again, the operations in the numerator match. So minus, minus. But the operations in the denominator are different. So where you see plus became minus, here minus will be plus in the denominator. That's the rule for the expansion of the tangent of a sum or the tangent of a difference. Let's go do a practice problem, which we just saw. The first one would be, well, technically, practice problems right here. But let's go do a homework problem that counts. The first one being 8. So the good news is the root 6s and the root 2s and the 4s are gone. The tangent values are going to be completely different. So we have to actually work through this, which is fine by me. So we're back to breaking this thing down. These angles are still really familiar. 11 pi over 12, it's still going to be all 1 pi over 12 and 5 pi over 12 reference angles. So you're going to break them all down the same way. I'm still going to go ahead and let this be the tangent of, I want my pi over 4 in the form of 3 pi over 12. And again, we'll just do a sum. To get to 11, if I already have 3, I need 8 more pi's over 12. So there, it's broken down. That part should be pretty easy by now. You reduce these. So you're really doing tangent of factor out of 4, 2 pi over 3. And 1 pi over 4. All right, so again, we got to expand. This is a sum, so my numerator should be tangent of the first angle plus tangent of the second angle. My denominator should be the number 1 minus the tangent times the tangent. All right, so the good news is we theoretically already know all the values of tangent at 45 and 30 and 60. But just in case you don't, we can refresh. Tangent of any angle is y over x, which means tangent of a 45-degree reference angle. Well, remember the coordinates at 45 were root 2 over 2 and then root 2 over 2 again. So if the y coordinate's root 2 over 2 and the x coordinate's also root 2 over 2, then those values pretty quickly cancel each other out and give an overall value of just 1. So tan 45 is 1. You should definitely just commit that to memory. That's going to be our easy one. Then the tangent of 30 and 60. I spent some time in class talking about how these are a lot like the sine of 30 and the sine of 60. Like you know that sine of 30 is either 1/2 or √3/2, right? And you're maybe sometimes you're just not sure which. And you might remember that the trick I gave you for that is you just literally look at the diagram. And you can see that a 30-degree reference angle has a long x and a short y. So you knew the x then was the √3/2 because that's a bigger number than 1/2 is. You knew the y was 1/2, right? You can't really do the same thing with tangent because tangent is a ratio of these values. You take these values and you divide them. So I don't know. Whatever. We just have to kind of muscle through this and then memorize it. But tangent of 30, since we just labeled 30, if tangent's y over x, then we know tangent of 30 would be the 1/2 in the numerator and the √3/2 in the denominator. And you can kill those 2's and you'll get 1 over √3. But you do have to rationalize that denominator. So multiplying by √3/√3 gives √3 over normal 3. So that's tangent of 30, √3/3. Now on the other hand, if you were evaluating tan 60, then now you're up here. And at your 60-degree reference angle, your little reference triangle, you can see it's got a short y and a long, it's got a short x, long y. So the coordinates have reversed, so 1/2 and √3/2. And so now suddenly the y coordinate that goes in the numerator is the √3/2. And the denominator is the 1/2. And when you kill the 2's, you just get √3/1, which is just plain old √3. So tangent of 60 is √3. So now's the time to just commit those to memory if you haven't already. The two options for the tangent of 30 or 60 are √3/3 or just plain old √3. And as long as you set your brain to like degree mode, then you can remember that the tangent of 30 is the one that has 3 in it twice, right? 3, 3, 3. The one with all the 3's is the √3/3. Now that falls apart. I don't want anybody to blame me. But if we're in radian mode, please remember that 30 is pi over 6. And 60 is pi over 3. So this little trick I just said is not very good because if you let your brain slip into radian mode, you're going to go, oh, Mr. F said that the one with the 3 is the one that has 3 in it twice. But in radian mode, that doesn't work. Tangent of pi over 3 is √3, the one that only has the 3 in it once. So I don't have a great cheat sheet thing for this. Maybe we could say, probably the better thing to say is maybe just keep going on who's bigger. √3/3 is clearly smaller than √3. √3 is √3. √3 divided by 3 would be 1/3 of √3. So this is the smaller one. And who's the smaller angle? 30 is. So the smaller angle does have the smaller tangent value. And hopefully you guys will just remember that pi over 6 is actually smaller than pi over 3 because you're dividing by a number that is bigger. When you divide by a bigger number, you get a smaller end. I'm going to shut up. Just memorize it for the love of God. So anyway, after all that jibba jabba, we're going to come back over here. We're going to remember that 2 pi over 3 is still a pi over 3 reference angle. So it is going to be the √3, but we're in quadrant 2, so it's negative. So this expression here is negative √3. Plus 1 all over. 1 minus negative √3 times 1. So this is it. That's our answer. It's just in a very ugly form. I'm going to scroll down and give myself some room. Okay, there's my little line that I'm not supposed to write below. Here's my little thing representing my face, so I don't write behind my face anymore. All right, how do I clean this up? First thing to do is, I don't know, whatever you want. This numerator, I'd probably reverse it. Just make it 1 minus √3. Just cause. My denominator is 1 plus √3 plus. And then that's good. I like the top and bottom to match. If it's number then radical, I like the bottom to be number then radical. Now I wouldn't mind if it was radical number, but I don't like to see like 1 plus root 3, and then have the numerator be negative root 3 plus 1. That feels out of whack to me. So I always flip it if I can. And it's not necessary at all. It's just something I do. So what do we do from here? This looks pretty clean. This looks like a good answer, but it isn't, because we have radicals in our denominator. So we know that if we want to get rid of it, we'll multiply by the conjugate of the denominator. So if we multiply 1 plus root 3 by 1 minus root 3, we know that the result will no longer have a radical in it. It'll become a nice, clean, rational number. But whatever I do to the bottom, I do to the top. Now what we're doing is we're foiling. So I'm going to go first times first. 1 times 1, that's 1. Then I do my outers, and I get a negative root 3. Then I do my inners, and I get another negative root 3. Then I do the last times the last, and I get a positive. Root 3 times root 3 is technically root 9, and the square root of 9 is normal 3. So this is my numerator expanded. In the denominator, 1 times 1 is giving 1. Then the outers is giving me negative root 3. But the inners, because of the opposite signs, is giving me positive root 3. And those will cancel out, which is the whole point. And root 3 times root 3 is, of course, normal 3, negative 3. No radical anymore. So we see that the 1 plus the 3 is a 4. And negative, negative gives me negative 2 root 3's. And 1 minus 3 is negative 2. So the only thing left to do now is divide the 4 by the negative 2. And divide the negative 2 root 3 by the negative 2. So we can simplify. Or another way to think about this is we're factoring a negative 2 out of the numerator. Factor out a negative 2, and the 4 goes to negative 2. The negative 2 root 3 goes to plus root 3. And we're dividing by negative 2. So then that cancels. So however you want to think about it. If you want to think about factoring out of the numerator and then canceling, be my guest. Or you can think about just, dividing the first term by this and then dividing the second term by this. You got to divide them both though. And then you land on an answer of negative 2 plus root 3, which I think is fine. If you wanted to flip this around the plus sign and make it root 3 plus negative 2, or root 3 minus 2, I don't actually love that. We run into trouble of like, hey, how long is the radical? Is this actually root 3 minus 2, meaning root 1, which is 1? I don't know. Notationally, I like for my radicals to just come last. And you guys know my long-standing hatred of negative leading coefficients, so to speak. I hate negatives that come first, but I still prefer it to not having my radical last. So this is actually the form I would leave my answer in. So there's an example of tangent getting done. All right, how many answers are there going to be for tangent, by the way? Just 4. Could you memorize them all? Yeah, you probably could. Is it even 4? I think it might only be 2. There's that one and there's that one. And there's that one and there's that one, which is just the negative of those. Yeah, so I guess there's only 4 different possibilities. You could memorize them all. All right, I'm going to move on. So 10 is a degree, and we can do it. Why not? Delete. Just move that. All right, again, I'll talk about how you don't have to do this one as written, right? I'm asking you for the tangent of 435, but you should know that that'll be the same as the tangent of 435 minus 360, right? Because those angles would be coterminal. So if you subtract away 360, you're finding an angle that's coterminal with 435. So of course it has to give the exact same value for tangent. So that would be tangent of, again, this is what I'm super bad at, 75. Oops. But so we could absolutely do this as tangent of 75 knowing full well that the tangent of 75 is exactly the same as tangent 435. And that opens the door for you to just do this as the classic 30 plus 45. Two super basic angles. And that would be fine. I would give you full credit on the assessment if you chose to evaluate at a different angle using either coterminal angles or using reference angles and potentially making it negative if you had to. Now here I don't even have to because 435 is in quadrant 1 anyway. So as you rotate around 360 plus an extra 75, you're talking about a quadrant 1. You know that this expression should be positive. So if you re-express it as tan 75, that's obviously still quadrant 1, so we'll still be positive. I don't know if I'm doing this. I just don't feel like it, but okay, fine, I'll do it. I'm going to be really lazy about it though. So it's going to be tan 30 plus tan 45. It's going to be all over 1 minus tan 30, tan 45. That's messy as heck. I'll try to be cleaner in the next few steps, but up here, we know that the tangent of 30 is actually root 3 over 3. And then tan 45 is, of course, still 1. Then you got 1 minus root 3 over 3 times 1. So this is definitely looking uglier than the last one. If you remember the last one, we didn't have the root 3 over 3s. We just had root 3. So we kind of avoided the complex fraction problem. We just had sort of a fraction. But we now have fractions inside of fractions. But I told you guys in class, that's no big deal. The first thing I would do if I were you is just multiply through by 3 over 3. Because that 3 will distribute onto this and kill the 3 in the denominator. And it'll distribute onto the 1 too. So if you choose to do this, you're going to end up with just root 3 plus 3. And in the denominator, you'll have 3 minus root 3. So you're here now. So the whole root 3 over 3 thing is no big deal. You just multiply by 3 over 3 and you can clean it up real fast. Now I did say I don't love seeing these things out of order. So the numerator here could just be rewritten as 3 plus root 3 over 3 minus root 3. But the more pressing thing is we're really not allowed to keep this radical in our denominator. So we'd better multiply by the conjugate, so 3 plus root 3 over 3 plus root 3. So now from here, I'm going to move a little bit diagonally down and away from my face. But you're going to FOIL this out. Again, you might want to throw parentheses around this. In the numerator, you're going to go 3 times 3, 9. You're going to get 6 root 3's in the middle. And of course, root 3 times root 3 will be another 3. In the denominator, when you FOIL, you get 3 times 3 is 9, but then you get a negative 3 root 3 and a positive 3 root 3 that cancel. Something's fishy here. You're supposed to be a root. Okay. And then you go negative root 3 times root 3 and you get minus 3. So we are now looking at a 9 plus a 3, which is a 12, plus 6 root 3, all over 6. And so finally just divide. 12 divided by 6 is 2. And 6 root 3 divided by 6 is just the root 3. So there's your answer. 2 plus root 3. And what did we get before? We got negative 2 plus root 3. Right? So whatever. I guess I'll point out nothing. I won't point out anything. What will I point out? Yeah, sure. I'll point out that the square root of 3 is like 1-ish. It's a little more than 1. So negative 2 plus something that's only a little more than 1 is still negative. So you guys hopefully are recognizing this is still an overall negative thing, which makes sense because what were we evaluating? Tangent of 11 pi over 12, which was where? It was this guy, right? The 1 pi over 12 reference angle from quadrant 2. Should tangent be negative over there in quadrant 2? Yes, it should. So looking at our expression, that is a negative thing. So if you had 2 plus root 3, a positive plus a positive, you'd know that's positive. And the tangent of 11 pi over 12 has no business being positive. So you could go back and you could say, all right, I must have blown a minus sign somewhere. And you could figure that out. But you should definitely be thinking about, like, hey, should my answer be negative or positive? At least you should be able to think about that and double check your answer that way. So again, speaking of, 2 plus root 3 is positive. Should our answer be positive? Sure. We're evaluating tangent in quadrant 1. It should be positive, right? I'll make one more little observation. And, again, some of you will understand, some of you might not. But I keep saying this, I'm going to keep saying it. There's only 2 positions that I'll ever ask you about. And it's the 75-degree reference angles and it's the 15-degree reference angles. Now both of these should have positive tangent values, right? So tangent 75, we just figured out what that is. It's 2 plus root 3. Well, what would tangent of 15 be? It should still be positive, right? And who's bigger? Root 3 is bigger than, no, the 2 is the bigger thing. So guess what? 2 minus root 3 actually still has an overall positive value. That's gonna be what the tangent of 15 is, right? It's gonna be the smaller of the 2 numbers, but still positive. So 2 plus root 3 is positive and big. 2 minus root 3 is positive but small. And so we actually, again, can memorize these tangent values. I don't know. To the non-believers, clear. Tan 75 should be the guy that's positive and big. If you can just memorize that we're talking about root 3's and 2's, then root 3 plus 2 gives us the right answer. For a tangent of a 15-degree reference angle, I should still be positive, but I should be relatively small. So that would be the bigger thing, the root 3. Oh, that's not the bigger thing. I'm sorry. 2 is the bigger thing. So it would be 2 minus the root 3. That should still be overall positive. It should still equal tan. These things are actually very memorizable. Okay, again, you have to show your work. But you should know going into the problem what answer you should be getting. If you're like really studied and if you're really well prepared for the quiz, you should know what the answer is supposed to be, and then you just do the math and make sure you find it. Okay. I don't know. Let's do one more. So what would be a super negative tangent? Well, the tangent of negative 75 would be, that would be quadrant 4. That should give me the largest possible negative. So how would you get that? You'd need a negative 2, and you also would take away the root 3. So negative minus, that's going to be the biggest possible negative. There you go. Tangent of negative 75 would be negative 2 minus root 3. What would be our sort of small negative? Well, that would be the tangent of negative 15. That's this. How do I get a small negative? Well, that would be root 3, take away 2. Oopsie daisy. Outside of the radical. Remember, 2 is bigger than root 3. So if I do root 3 minus 2, that'll be negative, but just a little bit negative. Boop, I did it. Although I did say I didn't want you to express it like that, didn't I? I did say I'd rather you did it as negative 2 plus root 3. Oh, crap! Probably shouldn't have screamed, oh, crap. Can't edit that out, can I? Anyway, this was a gigantic waste of time because I wasn't showing you my keystrokes on the calculator. And I'm still going. So I wish I had moved that up to there and then refreshed my stream. Hey, look at all this cool stuff I did on the calculator. That actually would have been really good. I'll do it again. We're 24 minutes in on this video. I can't fix this. Maybe we'll use a timestamp or something. I'll tell you just to jump ahead in the comments. But what I was trying to say was, oh, God help me. Tangent of 15 is that. That should be a small positive number. And if you know that you're working with 2's, well, 2 is 2. and you know you're working with root 3's. Root 3's are only 1.7s, right? So if you know the tangent of 15 should be a small positive number, then it's going to be 2 minus root 3. Oh, look, I did it. I figured out what tangent of 15 is without doing any fancy talk. On the other hand, tangent of 75, a 75-degree reference angle, that should be the larger value of tangent. That would be the 2 plus the root 3. That would give me the greatest possible value from a 2 and a root 3. Would be adding them together with both of them positive. Boop, I did it. Tangent 75 is 2 plus root 3. Got it. All right, and then I was trying to say tangent of negative 75. Well, that's tangent in quadrant 4. This should be a very big negative number. So to get a big negative number, you'd need negative 2 take away root 3. Basically, both are negative, and you want what they add up to. So up there, I did it. Like, this is all I'm trying to say, is that you can memorize these. Again, shout out to Eliza. Yeah, there's only 4 possible values to memorize, so you should absolutely be able to memorize them. Tangent negative 15 being the other one. That should be a small negative. And you could get that 2 ways. You could say root 3 is small while 2 is big. So if I do root 3 take away 2, that's going to be a small negative. There you go. Tangent of negative 15 is that expression. Although I did say negative 2 plus root 3 is sort of the way I'd prefer you to give that expression. But it's still worth the same thing, right? So I wish I hadn't blown this, but there it is. There, the calculator's there. You can see what I'm doing. You get what I'm talking about. I hope you get what I'm talking about. If you don't get what I'm talking about, then guess what? Ask me. Ask me in class. All right. Am I doing more, or am I done? Probably done. I'm not done. There's another one. Negative, blah, blah, blah. So fine. I'm probably not going to do this one, but I will say one more thing. Guess what? We have recently learned about symmetry identities, haven't we? What am I doing? We learned that tangent is an odd function. So if you guys don't feel like doing tangent of negative 7 pi over 12, then you can do tangent of positive 7 pi over 12. And just remember that with an odd function, if you take away the negative from the parentheses, you're going to generate a negative. You're suddenly going to get the opposite value when you take away the negative, so you have to put a negative on it, so that if what you're getting is now negative when it should have been positive, then negative of a negative thing will be a positive. So that's the only thing I'll say about this is you can use our symmetry identities. Ugh, I ruined it again. What did I do? Oh, I remember. Okay. All right, we're here. You can use your symmetry identities if you want to re-express this as a positive angle, and it's just the opposite of the result. I don't think you should do that. I think if you were doing this, you would just do the old. Start with something positive. What's the smallest thing we could do? Probably the pi over 4, so 3 pi over 12. And then if you want to get a negative result, then just use subtraction and use 10 pi over 12. So I don't think using the symmetry identity to pull the negative out makes much sense, because I can still express this thing in terms of a positive angle and a positive angle and just subtraction, right? So I think that's probably still the cleanest way to attack this. By the way, where's negative 7 pi over 12? Zoop. That's an angle that rotates over to here. So that's a 75-degree reference angle, but it's in quadrant 3, so tangent should be positive and large. So guess what the answer is? 2 plus root 3. Nailed it. Memorized it. Mr. F rules. Should be that. Am I right, though? Of course I'm right. Okay, drum roll. Tangent. I think I did this. Didn't I do exactly this in class? Do by all over 12. So I'm in degree mode. Almost caught my own self. Make that a radian. So it should be that. And if you know anything, That's gonna be it. Did it. Did it without having to do it. So there you go. The answer should be 2 plus root 3. But do the math. You got to know how to do the math. You got to show your work. I'm done. Talk to me tomorrow if you got questions. Am I done? Yeah, I am. Okay, bye.